For those of you who don't know me, my name is Kim Monroe, and I am on the organizing committee and help organize these pre-conference sessions. So all input is always appreciated to our group. At the end of this, I will be sending you some sort of a survey to fill out, and we encourage you. We do look at those, we read them, and we're very interested in your feedback. Obviously, this year will be a little different, so it'll be helpful to know what worked, what didn't, as far as this online format, but also session topics that are of interest for next year. So things that you might be interested in. If it's expanding on something that Tom's going to talk about today or other topics, just let us know. Okay, so we're going to jump in here. Tom Albin is a licensed professional engineer and a certified professional ergonomist. He holds a PhD in industrial design engineering from the Technical University of Delft in the Netherlands. He's currently a principal at High Plains Ergonomic Services, LLC. Tom has been engaged in ergonomics consulting since 2001. He has extensive experience as a researcher, a corporate ergonomist, product developer, and a team leader. He was a member of the group that developed the HFES 300 guidelines for using anthropometric data in product design, and has published several articles on anthropometry and is active in the US and international standards community. Tom's consulting and research has been principally concerned with physical ergonomics in office and industrial environments. He currently project deal with applied anthropometry evaluation of injury risk during push and pull tasks and the benefits of ergonomics to enhance operational efficiencies and work performance. So with that, I will pass you off to Tom and we'll get started.
Okay, thank you, Kim.
No problem.
Hello, everyone. Thank you for joining us today. I think since we're a small group, I'd like each person to just give a brief introduction. So I think, Kristen, can we start with you? You're the first one up on my screen.
Hi there, sorry about that. I pop up as Zachary Sestrick, but I'm Kristen. So I'm still working on trying to figure out how to change that. And I missed a little bit of what you were saying because I was still trying to change my name in here, Tom. Am I just introducing myself and where I'm from and what I'm doing? Okay. Yeah. So I work at Los Alamos National Laboratory in Los Alamos, New Mexico. I am a physical therapist and also now an ergonomist. I have my AEP and actually working a lot to learn more about applied ergonomics or what we call non-office ergonomics at LANL, Los Alamos National Laboratory. So excited to be here. Thank you so much.
Okay. Let's see. Dana?
Hi there.
Hi, Dana.
As Kristen kind of introduced herself, I also work at Los Alamos National Laboratory in Los Alamos, New Mexico. I started with the lab a little over a year ago, and I'm an office and non-office ergonomist. I'm a physical therapist by trade, just like Kristen. And yeah, I think the main thing for me for today is it's been quite a while since I've entered into any extensive research and statistical analysis, that sort of thing. It just wasn't really a part of my physical therapy practice for a couple of years. So now that I'm into the ergonomics realm, I think this is something that will become a very consistent part of my life. So definitely need to refresh on this type of stuff. So glad to be here.
Okay, so just to that point, we'll be talking about some statistical concepts today, but I'll try to be careful to define those, and we'll be learning how to use Excel or any other spreadsheet. I think Google Sheets and what is the Apple one? I can't think of the name now. Anyway, you'll learn some statistical concepts, but you won't be doing any real statistical analysis. We'll let Excel do all of that work for you.
Sounds good.
Okay, okay. Jane, please introduce yourself.
Hi, my name's Jane Lyle Mitchell, and like Kristen and Dana, we're all from Los Alamos National Labs, and I am also a physical therapist. We are all three trying to navigate through the applied ergonomics field and learn as much as we can. So that's why I am here today.
Okay, great.
Thank you.
Sure. Rachel.
Hello, Rachel Leach, and I work for BP in Houston, Texas. Certified professional ergonomist, and just recently kind of took over the global program for the company. So I'm here to learn as much as I can.
Okay. And are you a PT or engineer, or what is your technical background?
Yeah, I came from the industrial engineering side.
Okay.
So I'm an engineer by training.
Okay, great. Thank you. Keith.
Yeah, hi, Keith Osborne. I'm the ergonomist up here at Seattle City Light in Seattle, Washington. And I'm trying to remember exactly why I signed up for this a year ago. I think it's just, I just want to improve my knowledge base, and I'm very big into numbers and analytics and running a proactive ergonomics process like I do up here in Seattle. So I think that's why this interests me the most.
Okay. All right. I think that's everyone. You've heard my background. So let me just go ahead and pull up the slide deck to start. And let me go to full screen. Okay, so what I'm really trying to stress today is, if you look at a product design, a chair, for example, if you're looking at an office or a workstation out on the manufacturing floor somewhere, or those sorts of things. What I'm intending that you'll come out of this workshop with is the ability to do an analysis of that work site and to determine how many people will be physically accommodated by the dimensions of the workstation that you're looking with. So we'll have 6 different exercises. You'll be on your own to do those. It's a little different than if we were doing this in person. So each of those exercises, I've budgeted 25 minutes for you to do those. I'm sure that you'll have questions, so let's use the chat function to do that. I'm not sure if I will see those, so if I don't, if Kim doesn't see it and call it out, do feel free to turn your mic on and just ask your question, and we'll go from there. We'll try to take a break probably in about 2 hours, more or less. And I guess we'll just go from there. So here are my objectives. I want you to become familiar with various anthropometric data sets. There are several that are publicly available. With one exception, those are typically military data. And we'll talk about why that's a reason for some caution. We'll develop, second objective is to develop an understanding of methods to estimate accommodation for designs based on multiple anthropometric variables. So if we're looking at a chair, for example, we might look at the seat pan and say that we want to know how many people will be accommodated by a chair that is this many inches, a chair seat that is this many inches wide, this many inches deep, and this many inches above the floor. So it's those, how do we deal with multiple anthropometric variables? Sometimes the third objective, it's learning how to estimate accommodation for derived dimensions that are sums of measurements. So for example, when we look at the Army data, the answer data, we'll find that there isn't any eye height sitting from the floor. So if you're doing office type things, where to put that monitor is always a question, but we don't have a convenient statistic or a data set for that. So we end up combining things. We probably would use eye height above the seat sitting, and then popliteal height, combine those two. And we'll talk a little bit about how to do that, at least a couple of different ways of doing that, so that you get an accurate estimate of what that combined dimension is. We'll talk a little bit about how to estimate accommodation for design models. That is, if you're looking at the design of a workstation or a piece of furniture, and the only data that you have are percentile values. We'll talk a little bit about that. I don't think we'll cover that in any of the examples, any of the problem sets, but we will talk about it. And down the road, I'm happy to, if you want to ask questions, I'll be sure that you have my email address so that you can ask about that. And then the same thing as combining variables, we sometimes need to know when all we have are percentile data, how many people will be accommodated. So for example, if we go back to our chair seat example, we might only have like the 95th percentile values for hip breadth and popliteal to knee length and knee height above, or popliteal height above the floor. So how do we determine what percentage of people will be accommodated if all that we have to make that assessment with our percentile values? So here are some North American anthropometric data sets. Answer 2, which is the most recent Army data, was released in 2012. It's for adults, and it's, I believe, well, it is gathered on Army personnel, and you should have gotten a complete data set of that as part of the handouts. You have 2 Excel files for that. One is answer 2 males, and the other is answer 2 females. So the Caesar data, that was released in 2002. You can purchase the complete data set. The last time I checked, it was about $3,500. You can purchase that from SAE, or you can download the summary technical report for free at this link that's shown here. So a somewhat newer tool than either of the answer or the Caesar data is the HFES, the Human Factors and Ergonomics Society Virtual Fit tool. And this is US civilian data, adults. It's primarily based on Caesar data, but it's been updated to reflect the US, updated and weighted, statistically weighted to reflect the civilian population as of about 2014. It's also an Excel-based tool or spreadsheet-based tool, provides estimates of multivariate accommodation. So we'll have a chance to practice with that as we go through the problem sets. I did enclose a copy with your handout, but you can also download it from the HFES website. It's free to you, and this is the link. So the last one that I want to talk about that's North American data is the NHANES data. I think that's something like National Health and Nutrition something survey. It's done, I think, every year or two. It's based on US adults and children. It has limited anthropometric measurements, height and weight, for example. Only percentile data are reported on the website, and the link is given here if you want to go and look at that. For the HFES virtual fit tool, the NHANES data for 2014 were used to statistically weight that data so that it would be representative of the civilian population as of about 5, 6, 7 years ago. There's lots of data available for different countries, different regions. One that I typically recommend first is the ISO technical report, ISO 7250-2. And this has percentile data from 9 different countries around the world, Europe and Asia, and I don't think there's any South American data in it. So Europe, North America, and Asia. One of the nice things about it is that all of the data sets were compiled using the same measurement methodology. So there's fairly good consistency between country to country. You can purchase this from the International Standards Organization, and I believe the cost is about $175 US. So when you look at a data set, what are some of the things that you need to consider? Well, certainly you want to think about how well the selected data represent your intended user population. Then you want to look at how current are the data. Is it military or civilian data? A couple of things to think about is that height and length data are more consistent over time. So stature, height, arm length, leg length, those kinds of data are fairly consistent. The only caveat to that is looking at developing countries, and there you do see, as particularly where nutrition has improved in the past 10, 20 years, you will see some change in the height and length data. Where we typically see changes over time are the fleshy dimensions. So things like waist circumference, hip circumference, those kinds of dimensions tend to be increasing over time. And in some of the work that I've done, we've seen that changes by roughly 2 to 3% per decade. So some pretty consistent increases there. So I think the next slide shows some of this. So this is height from 1968 to 2002. The 1968, 77, 88, and 2012 data are all military data. You see here that the 5th percentile heights are pretty consistent over time, as are the 95th percentiles. We see a little bit of bump in the 95th percentile because this is civilian data. And one of the things that you have to be concerned about with military data is that not only are the people typically younger and fitter, but they're also younger, they're also younger, I did say that. But there are also restrictions on heights and weights for people that can be accepted into the military. So that's part of the reason we see a little difference in civilian and military height. However, when we look at the mass data, we see a steady increase from 1968, 77, 88, 2012 in the military data. And then here's our civilian data as well. So the lighter weight, the 5th percentile weight, that's a weight that is greater than or equal to 5% of the population, has stayed fairly consistent over the years, but we have seen this consistent trend of increase in weight. Just a quick review, what is a percentile? It's a measurement value, and for our purposes in anthropometry, it's a measurement value, a percentile value. It indicates the percentage of all measurement values which are less than or equal to some given measurement value. So let's say if the 20th percentile for height for females was, I'm just going to make a number up, 5 feet 4 inches, then we would expect that 20%, if we went out and randomly sampled women's heights in the population, we would expect about 20% of the height measurements would be less than that 5 feet 4 inch value. So we can also think of it as a probability that, in saying that the probability that an individual's height is less than or equal to the 20th percentile value is 0.2. So we'd be saying that if you went out and randomly surveyed women's heights in the population at large, the probability that they would be less than that made up 5 foot 4 inch height would be about 20% or 0.2. So here comes our first problem set. So what I would like you to do is go to your handouts. You'll find the answer to data for males and females. And what I'm asking you to do is to go through and determine, to calculate what the 5th, 50th, and 95th percentile values for popliteal height and eye height sitting for females are. Then the same thing for males. And then I want you to use a function called COUNTIF in Excel to verify that, in fact, 95% of the people, more or less, are equal to or less than the height, popliteal height. So let's take a look. Let me back out of this and I'll pull up the data set. So I'm just going to pull up the answer to female data. Oh, I need to reshare screen, sorry. Okay, so is everyone seeing my screen and you're seeing a big Excel data sheet?
Yes.
Okay, so what we're going to do is we're going to be looking at, these are the names of the different measurements that we're going to be looking at. So what you'll do is, for example, eye height. These are alphabetical. Okay, so here's eye height sitting. So that's column AI. And you're going to go over to an area where there isn't anything showing. And you're going to type in a statement that looks like this: equals percentile. And then it's a, I'm sorry, what did I say that was? I forgot the eye height. I think it's, yeah, it is a height. Okay, AI, sorry. Okay, so we're going to type IA, I'm sorry, I can't talk today. AI Alpha India 2 colon AI 1987, because that's the number of data points that we have. We'll just quickly run down here. Okay, so there are 1,986 data points. They start with 2. So that's why we used 1987. So then I'm going to put comma, and let's just do the 95th percentile. So I'm going to put 0.95, close parenthesis, return. And it tells me that the 95th percentile for eye height seated is 799 millimeters. Okay. So you need to do that for males and females. And then the last thing that you will do is verify that the 95th percentile popliteal height is correct. And to do that, you'll use a statement called COUNTIF. AI2, AI1987, and then quote, less than equal to 799, quote, close parenthesis. Okay. So that comes back and it tells us that 1,890 people had eye height sitting measurements of 799 millimeters or less, but we want to convert that to the percent of the population. So we just tell it to divide that by 1,986, and it tells us that 95.2% of the population are in fact truly less than 799 millimeters eye height sitting. Okay, I'm sure it seems a little awkward at first, but this is your chance to practice on it. So I'll be here. You can either ask questions verbally, and I think that would probably be best because I'm not sure that I will see the chat if you do that. So I'm going to stop sharing, and we'll come back in about 20 minutes and see how you did. And of course, if you have questions meanwhile, feel free to ask.
And Tom, it looks like we did have somebody ask about the equation in the chat.
Okay, so here is the percentile one, and I will put the, I'll put the COUNTIF up in the chat as well.
Tom, can you also add what we're supposed to be calculating?
Sure, if you go to your handouts, there should be some problem sheets there.
Oh, okay, thanks.
And it'll be problem set 1. You're going to look at 5th, 50th, and 95th percentile for males and females for, let me just double check, popliteal height and eye height sitting. And those are the only 2 that you look at. So you determine the 5th and 95th percentile values for I'm sorry, 5th, 50th, and 95th percentile values for popliteal height and eye height sitting for both females and males. And then you're going to use the COUNTIF statement to determine and verify that the 95th percentile values that you get are correct and that they are actually, that 95% of the people are that height or less. Okay, did everybody find their worksheets and the problems sets? Okay, I'm just checking in. How's everyone doing? Is
Doing well.
anyone done?
Yeah.
Okay. So I have one done. Let's see, I think Jane just switched computers, so she's coming up.
Yeah, it took me a little bit to get into my other computer and save the file as well to be able to work with it. So I'm a little bit behind as well, but
Okay. So
Yeah, you'll
go
have
ahead.
to count me out. I'm not even there yet, so
Okay.
I'll just follow when you're go
Okay.
through
Well,
the answers.
we've got another 5 minutes or so. So okay, just a couple more minutes and then we'll see what everyone found. Okay, let's go ahead and come back. And this is what you were asked to do, is to find the 5th, 50th, and 95th percentile values for popliteal height and eye height sitting for females, the 5th, 50th, and 95th percentile values for popliteal height and eye height sitting for males. And then finally, using the COUNTIF function in Excel, verified that the 95th percentile values for popliteal height are correct. Okay, what kind of problems did you run into? None? That's great.
So I think for me, this is Dana. I
Mhm.
think for me, it was just making sure that I was keeping the right column with the right percentage and pulling the
Yes.
right equation.
Yep. You know, if you do many of these, you're almost guaranteed that at some point you'll click the wrong column and you know, get some very strange looking results. So yeah, you just have to double check that everything's correct. Anybody else have problems or comments?
I think just from my standpoint, I don't use Excel outside of just putting, numbers in there. So I think I missed a couple steps because I just got stuck spinning my wheels trying to figure out, how to figure out what you were asking.
Okay.
And then scrolling down, I was thinking we were talking about, 1,987, and I scrolled down and I've got something like 4,000. So
Oh, you're in the mail data set.
yeah, okay, that's why.
Yeah.
So there, like, I think I probably wasn't super prepared because I am so new to Excel to
Okay.
navigate it in the way that you were
Okay.
asking us to do with the time
Sure.
that we are given.
Okay.
So.
Well, let's work on that a little bit then, because that's something I want all of you to be able to do. These are some check figures that I came up with, but let's go ahead and let me figure out how to do this. Stop share. I'll bring up the Excel files again. Oops, that's the wrong one. Okay, this is the female data. So let's go through the percentiles. We'll just set this up here.
Can you share it? Can you share it?
Oh, I'm sorry. Yes, let me remind myself how to do that. Thanks for keeping me on task here. Okay, so we're looking at the female data, and I'm going to do 5th, 50th, 95th. You would do this the same way with the male data, but just that you would put in some slightly different numbers. So we want percentile equals percentile AI, because that's the column with popliteal height. Whoops. Colon AI 1987, comma 0.05, close parenthesis. Okay, so we've got 698 as the 5th percentile. Now we'll do 50th.
And this is for eye height, right, Tom?
This is popliteal height sitting. Let me just edit that. Okay. So this is, we're going to do the 50th percentile now. AI2, AI 1987.5.
Popliteal is BO.
Yeah, I guess AI is eye height, isn't it?
Yes.
Yeah.
No, is it? I'm sorry. I'm very sorry. It is eye height. You're right. Okay. Yes. Okay. So this is our 50th percentile. The only thing that's really changed between these two is this 0.5. And then we'll do the same thing here.
So the A and the I correspond to the column that,
Yes, yeah,
Okay.
that's exactly. You're telling it, go to column AI and look at all that data and tell me what the 5th, 50th, or 95th percentile is, or any value that you put in there, really. Okay, so in this case, we're doing the 95th. 0.95. Okay. Is that helpful? Does that help clear up the
yeah, that
percentile?
helps. Thank you. I missed big pieces there. So thank you.
Okay. Okay. Well, we'll be practicing this several more times, so I'm sure you'll have it here in a minute. So let's go ahead and do the percent less than 95%. Okay. So this is where we'll use the COUNTIF function. That's one that doesn't get used typically, but so what we're going to do is we're going to ask it to look at that same column again, eye height. I got it right this time. So we're going to tell it to look at all of that column, and then we're going to ask it, okay, what number are less than or equal to 799 millimeters? And we have to put everything in quotes to do that. And then we close the parenthesis again, and it comes back and it tells us that 1,890 are 799 millimeters or less. And then to convert that to a percent, we just tell it to divide by 1,986, the number of data points. And it tells us that 95.16% are less than or equal to the 95th percentile value. Okay? Are you feeling a little more comfortable with that?
Like an inch.
Okay. All right. So let's go ahead then, and we'll go back to look. And let's see, are you still seeing Excel, or are you seeing a PowerPoint slide?
No, yeah, we see Excel still.
Okay. Okay, so here's the check figures. If you want to take just a minute or a couple of seconds to check. So here, here's our 95th percentile value for eye height, 50th, 5th. And then when we checked, it's, it was roughly 95% for both males and females. Okay, so let's go back to full screen here. Okay, so there are a couple different models of anthropometric dimensions. Univariate models, and those are dimensions for a product or a workstation that consist of only one measurement. So if the only thing we were interested in is chair seat height, we could look at popliteal height for that, and a percentile would be a great tool, a great piece of information. The problem is that most of the things that we end up dealing with are multivariate. That is, they have combinations of more than one measurement. So there are a couple different ways of looking at this, and I tend to think of it as sums and sieves or sieves. I'm not sure quite how to pronounce that, I guess. So again, we might look at seated eye height above the floor. And in the answer, the Army data, that's not given as a specific dimension. So we might want to think about, well, how could we approximate that by adding popliteal height and eye height above seat for each individual in the population. Pretty straightforward to do in Excel or any other spreadsheet. And then you can do your percentile analysis and get your accommodation estimate. The other one that we tend to see is how many, and we talked a little bit about this earlier on, but for the chair seat height, width, and depth dimensions, we've got 3 different measurements there. If we use percentile values for that, how many people are accommodated? If we use, for example, the 95th percentile value for each one of those 3 dimensions. And except in a very rare case where they're all perfectly correlated, it will always be less than the percentile value you use. So if you use 95th percentile value for seat width, 95th for seat depth, and 95th percentile for seat height, you won't accommodate 95% of the people. It'll be something less than that. And we'll look at that in a little bit. So univariate or single dimension anthropometric models, percentile data are perfect for that. So if we looked at the chair seat height, the 5th and 95th percentile popliteal height values are the boundaries of the range of seat height. So if we think of this as the normal distribution for popliteal height, we know that 90% are between the 5th percentile value and the 95th percentile values. Okay. Questions? Okay. So this is an example, another problem set. So we're going to look at designing a cart. This is a cart that's designed to be pushed or pulled by hand. So we're going to look at these dimensions. 5th percentile female waist height, the Omphalian value. This is the name of the dimension that you'll find in the data set. Waist height Omphalian, that's the first dimension you look for. And I think someone mentioned it earlier, depending on which data set you're in, your Excel statements will have different values. So for example, when you were looking at eye height for females, it was AI2 to AI1987. When you look at males, that would have been eye height AI2 to AI4083. So to be sure that you don't get caught up with that when you're doing this problem set. Okay, so the next thing that we're going to look at, the next dimension we'll look at is 5th percentile female shoulder height. Acromial height is the measurement that we'll use. 95th percentile female waist height, 95th percentile shoulder height, 95th percentile male waist height, and then calculate the heights for a cart handle that will accommodate a 5th percentile female or a 95th percentile male. What is the range of heights? Those of you that are doing non-office type work, where do we typically recommend to put the handle for a cart that you're going to push or pull? Anybody? So typically we say waist height. So when we're looking at this cart design, we want to know what the handles, where the handles should be. So we're going to put the handles at waist height. So your first question is basically, what's the 5th percentile female value for 5th percentile waist height? And what is the 95th percentile handle height or male waist height? Okay, so then the next thing that you're asked to do is to assess the risk to the shoulder from someone pushing this cart. So to do that, we want to find the distance between 5th percentile female shoulder height to her waist height. That's going to be the lever arm that her shoulders will be working against. So you're going to determine what that is, and it will be the difference between the 95th percentile shoulder, it'll be the difference between the shoulder and the waist height for a 5th percentile female and a 95th percentile female. So you'll find that distance, and then you'll multiply it by 50 pounds of force. And that should give you foot pounds or inch pounds, which then you could translate into risk value for shoulder stress as they're pushing a cart. So remember, everything in answer 2 is in millimeters. So to convert from millimeters to inches, divide the answer 2 data by 25.4, and that will convert millimeters to inches. Questions before we start? Okay, all right. Let's take about 25 minutes to do these. I'll be here. You can ask questions or you can send a chat question and we'll go. So let's come back in about 20-25 minutes and see how it worked. Okay, I'm just wanting to check in and see how everybody's doing. Any questions, problems?
No, I just got stuck on number 7 for about 5 minutes until I figured out that I had to divide my numbers by 12 to get foot pounds. And then my numbers made a lot more sense.
Okay, good. All right, good. Are you getting more comfortable with the percentile function in Excel?
Yes,
That's the question to
definitely.
everyone. Okay, good. Well, now that you're comfortable with that, we'll switch to something else. So.
Cruel, cruel.
Yeah, cruel to be kind, I guess. Okay, let's take a couple more minutes and then we'll compare notes. Okay, let's pick this back up again. I've got the check figures on the screen. At least I hope I'm sharing that. Does everyone see my PowerPoint slide with check figures?
Yes.
Yes.
Okay, great. Okay, questions about what we just did? Comments?
I was still super slow at it, but at least I got it all done this time. So.
Oh, good. Excellent. Good for you.
Yeah.
Okay. So I think this is just my personal bias that one of the things that I think we don't look at enough in manual cart handling is we look at back loads, back stresses, but we tend to pay less attention to shoulder loads. So I just thought it would be fun to look at what kinds of stress is being put on the shoulder. Any questions or comments before we switch to something slightly different? Okay. Okay, so in this case, we're going to look at eye height above the floor. I've been telling you about this. Let me go to full screen so that's a little bigger. This is actually a drawing from an ISO standard, as you see here, 11064-4, which is the design of control rooms, if I remember correctly. So you can see this is you're probably seeing drawings like this. So here we've got eye height above the seat, and we've got seat height, but we don't have anything that's eye height above the floor. And typically that's something that we're very interested in offices. So we're going to look at different ways that you can combine those. And let's see what. Okay. So this is a situation that comes up sometimes is, for example, if you look at the ISO data, the 7250 part 2, they give percentiles, but they also give the mean and the standard deviation of two variables, or multiple variables. So they typically give the 5th, 50th, and 95th. But suppose you wanted to know what the 75th percentile value was for something or for two variables. So in this case, we're going to look, there's a way to do that by assuming that the data have a normal distribution. So we're going to look at adding a couple of different variables. When we do that, the mean or the average of the combined variable C is equal to the mean of A and the mean of variable B. So that's pretty straightforward. Then we get into this thing of we have to calculate the standard deviation of the joint distribution, and we end up with an equation like this. So it's the variance of variable A plus the variance of variable B plus 2 times the correlation coefficient between the two variables times the standard deviation of A times the standard deviation of B. It looks a little more complicated than it is, and you won't be doing that, fortunately, but I did want to point it out to you. So what we want to do is, how do we determine the 75th percentile value when we combine two variables? And if we know the mean and the standard deviation of the population, such as is given in the ISO 7250, you can calculate that using the normal distribution. So in this case, we know that if we know the mean and the standard deviation of something, we can calculate what the 95th percentile value is. We know that from statistics that the mean, which is roughly about here, plus 1.645 standard deviations to the right, we know that roughly 95% of the population will be less than or equal to that value. So that's what we're going to do. Okay, so let's look at this of if we have two summed percentile values, we have eye height sitting and popliteal height, which you looked at earlier today. And we want to know what the, in this case, we've used the 95th percentile, but we could put any other percentile value in there that we wanted, 75th, 50th, 23rd, whatever. So the way we need to know 3 things. We need to know the average, the mean of the joint distribution. We need to know the standard deviation of the combined or joint distribution. And then we need to know the appropriate Z value that's associated with 95% or 75% or something of that sort. So that's where this statement comes in. If you use Excel to do this, you would type in this statement, norm S inverse INV, then the probability. So that would look like, let me just put that, let me type that in for you so that you can see what that would look like. So you would have equal norm SINV. So what value would you like to know? What percentile value? 75th, let's say 75. So we'll put 0.75 in. So that's your Excel statement. It will come back and tell you what that Z value is that you would put here in this equation. So if we did this for 95, we'd type this statement into Excel and it would come back and tell us 1.645 is the Z-score associated with the 95th percentile value. So then we can calculate our seated eye height above the floor. We combine the means of the two populations, eye height, popliteal height. That gives us our combined. Then we go through this process to calculate our combined standard deviation. And then we calculate using this formula what the 95th percentile value is, which turns out to be 1,315 variables. So I think, well, let's just go on here. I think I'll talk about, I'll just work through this problem set with you. I won't ask you to do this one, but we'll go ahead and work through it online, and then we'll go on to some of the others. So let me bring up Excel. And okay, so we're looking at the female data, and we have, let's see, we have 2 heights. So I'm just going to do something over here. We'll clear all this out. Okay, so let me look at my notes here. So we're going to be looking at popliteal height equals VO2 plus popliteal height, which is, I'm sorry, I just did. I'm sorry, I'm on the wrong data set. Okay. So for this one, we're going to look at acromial height and waist height. Sorry, I was telling you the wrong data there. So we want to add those together for each person. And we're going to look at the averages. So to do the average, we type average CM2 colon CM. This is female, 1987, close parenthesis. And it tells us that the average for, that must be eye height, is 980 millimeters. Then we can do the same thing for 2. Okay. So we're looking at acromial height and waist height. We can add those together. And that doesn't seem right. What did I do wrong? Okay. Well, according to what I've done here, we've got female eye heights of average eye heights of 2.3 meters. So clearly I've done something wrong. And what did I do? We want acromial data. So let's look over. Oh, I probably used standing. Okay. Clearly I have, and I'm not, I think I've used the wrong dimension here. I'm pretty sure that this is standing eye height. Okay, so let me just show you what I wanted to illustrate in terms of Excel skills for this. So here's the average of the two, even though this is wrong. But there's another way to do this in Excel, and that's what I wanted to show you. So this is C2 plus CM2. So that's just adding those two measurements for this single individual. Yes. Okay. Now I can copy that for all the individuals by this little trick. And it tells us. So now we can do operations on this combined set of data. And let's do average. Okay, and it comes out just slightly different, 1 millimeter difference between the two different ways of computing the average. If we were going to do that with this normal distribution approximation that I showed you, we could do some different things. This is the average. So now we need the standard deviation, and we can do that in Excel as well. Okay, and then we need to know what is the Z value or the normal value that's associated if we want, for example, the 95th percentile. So I'm going to show you how to do that as well. Norm V 0.95. Tells us that that's 1.645, as we said earlier. So now what is the 95th percentile value? So we want to go average equals average plus 1.645 times standard deviation. And that tells us 2507. So now we can, that's the calculated. And we can also, as you saw earlier, calculate it based on oh. 2496. So these are fairly close, but not quite. And what that's telling us is that basically these data are almost, but not quite perfectly normally distributed. So let's go ahead and go back to the PowerPoint. Any questions about how these exercises, how this exercise was supposed to work? So we introduced some new Excel functions, the average or the mean, standard deviation, z-score values. We talked about how to combine two different measurements, and what else did we cover? Calculating the 95th percentile or any given percentile based on a normal distribution, and then also on the actual data itself. Questions? I hope I haven't confused you too much here. So let's go back here, and these are some, oh, I'm sorry, I have to stop and reshare again. Okay. So here's the what should have been the data for this, and I think we'll just move on. Okay. So in this problem set, we're going to do a couple of different things. We're going to find the percentage of males whose measurements are less than or equal to the 95th percentile value for both popliteal height and eye height sitting. We're going to use a count ifs function that's very similar to the count if, but you just compare two or more different columns at the same time. So we're going to do this a couple of ways. And what a common problem is, that people will do when they're working with data is that they take the 95th percentile value of popliteal height and the 95th percentile of sitting eye height, and combine those two and assume that they'll get 95% accommodation. It turns out that's not the case. So the point of this exercise is to determine that from the data for yourself. So let's go ahead and start this next problem set. So you'll look at the 95th percentile value for popliteal height and eye height sitting, and you'll use a statement count ifs, and okay, I'll make sure I get on the right problem assignment this time. And I'm going to switch over to Excel and we can walk through this. Okay, this is the female data. Oh, cancel. put that away and open the mail data. Okay, so I've got my mail data. We have 4,083 dimensions, and we're going to look at.
Can you share that, please?
Oh, I'm sorry, I forgot to. Thank you for reminding me. Okay, so we're going to look at popliteal height and eye height sitting. So the first of those is eye height, which we'll find over here. So that's AI. You've worked with that before. And then we're going to look at popliteal height, which is here, BO. So the first thing you're asked to do is to use your count ifs function. So I'm going to show you how that works. Equals count ifs. I need the percentile values. Okay, sorry, I got ahead of myself. Okay, AI, BO.
You might have mentioned this already, Tom, but do you make any adjustments to this for clothes or shoes when you're using the answer to data?
That's a good point, Kim. The answer to data are barefoot, minimally clothed individuals. So you often will need to make some allowances for things like shoe height, clothing allowance, those sorts of things. There are some values that are commonly used, but for example, for shoe height, heel height, it's anywhere from 25 to 40 millimeters. Clothing, it's pretty much arbitrary. And again, it depends. Are you working in a heated office, or are you wearing Arctic gear? So you can and should make allowances for clothing, but it really varies depending on what the application is. Okay, so
Thanks.
yeah, we've got our 95th percentile values for both of these, AI and BO, or popliteal height and eye height sitting. So now we want to determine the percentage of people that are less than 95th percentile values for both of these two variables at the same time. So we're going to use the countifs function equals countifs. And just like countif, we have to put our quotes in, then less than, equal to 860 millimeters, quote, close parenthesis, Whoops, not yet, close parenthesis. Then we bring in our second column, BO2, BO4083, less than or equal to 1350. Now close parenthesis. Okay, so it tells us that 3,885 of the 4,082 measurements are concurrently less than those two measurements. And we'll convert that to percent here very quickly. And look at that, we actually hit it on this one. So we got 95% accommodation, and that's not the usual case, but in this case it did happen. So a different way to do that would be to combine them. And we could do that again, AI2 plus I plus BO2. Copy that. And then let's see how, okay. So I'm just going to add those two 95th percentile values together. Okay, and then I'm going to use COUNTIF. Okay. And it tells us that nearly all of them are less than those two values. So the point that I'm trying to make here is that adding the two 95th percentile values together is misleading, because it tells us that 4,082 are less than the sum of the two 95th percentile values. But when we actually went through and counted, it was 3,885. So we're off by about 200 if we simply add the two percentile values. Okay. Questions? Okay. I think it's probably a good time to take a break. So why don't we plan to come back at 2:20 my time? That's about 15 minutes from now. Okay. So I will see you in about 15 minutes.
Thanks, Tom.
Sounds good. Thank you.
Sure. Okay, is everybody back?
Yes, sir.
Looks like everybody's here. Okay, so for our next exercise, we're going to use the HFES virtual fit tool. I think you'll find it's a little easier to use. So this is what the virtual fit tool looks like. Let me see if I can get it. And does everyone see a virtual fit tool, multivariate accommodation testing tool? No? Yes?
Yes.
Yep.
Yeah, we're able to see that.
Okay, good. Thought I'd lost you there for a second. Okay, so this is a tool that does basically the same thing that we've been doing by brute force using Excel. So our fifth problem set looks at chair seat design. You'll put some values in here, and then you'll see that it tells you how many people are accommodated. So I just want to go over this for a little bit before we start on it. So you only change values that are in the green cells, okay? So this one tells us what fraction of the population is male. So if it's roughly a 50-50 mix, then we'd put 0.5 here. But let's say it was, 70% female workforce that you're working with. So we would change this to 0.3, okay? So that's gonna tell us that our working population that we're gonna compute the anthropometry for is 70% female and 30% male. So you can change that. You know, you could say that it's all male. You could say that it's no males. You can put anything in there that matches. Typically, people leave it set at the default of 0.5, but again, you can change anything that you want there, as long as it's between 0 and 1. Let's see if I can get this a little better, a little larger. Okay. So, just play with this so that we can see everything all at once. It's a little small. Okay. All right. So we've set our composition of the population, male or female. Then you see that we've got, you know, a group of measurements here. So stature, body mass index, Abdominal extension depth, that's the distance from your back to the front of your abdomen. Buttock knee length, that's the length of from the person's buttocks to the popliteal, to the back of the knee. I'm sorry, I've done that backwards. It's the distance from the buttocks to the front of the knee. Buttock popliteal is, of course, the buttock to behind the knee. Elbow rest height sitting, eye height sitting, forearm breadth, and all the way down. So these are all seated measures. There are also a few standing measures. So this tool was designed pretty much to look at seated work for the revision of the ANSI 100 standard, the computer workstation standard. So how does it work? Well, let's say that we put 5th percentile female value in here, and that tells us that it's 1,501 millimeters. So you're going to see some information pop up over here as soon as I hit return. Okay, so it tells us that almost 100% of men are taller than 1,500 millimeters, and approximately 95% of women are taller than 1,500 millimeters. If we look at our 50-50 mix, it's going to tell us that 97.3. So we can, again, if we change that, let's say that we only want 10% male, then the only thing that really changes here is it tells us that what proportion of the population is accommodated changes, because we're now looking at a 90% female workforce. Okay, so let's say that we wanted to look at two measures at the same time, and I'm just going to clear these out. Okay, so let's look at what would be a good one to look at. Let's look at shoulder breadth. So we're going to look at what's the range of shoulder breadths if we were designing something like a backrest for a chair or something that sort. So we want to accommodate 5th percentile female, which is going to be here, 387 millimeters. And it tells us that, again, 95% of females are that height, or I'm sorry, have that shoulder width or wider. Nearly 100% of men, 97% of both. So this is telling us what percent of the population is greater than the measurement value that we put in the left-hand column. Now, if we put one in the right-hand column, so let's put the 95th percentile male in there, value in there. It's going to do something a little different. So now it's telling us what percentage of the population are greater than this measurement and less than this measurement. So it tells us that both together are about 94% accommodated. So not too bad. Just, you know, that's telling us what we've got. If you look down here at the bottom, you'll see the total accommodation. And because we're only looking at one variable, it's exactly the same. But as soon as we start putting multiple variables in, we'll see that change. So let's just say I wanted, for whatever reason, to look at popliteal height, and I'm going to use the 95th percentile male value. So you'll see some changes if you watch down here. Okay, so now it's telling me that even though I've got almost, well, better than 94% accommodation on both of these variables independently, when I look at them both together, I've got only about 92%. So that's the problem with using percentile values to estimate accommodation, is that the common misunderstanding is that if you use 95th percentile values for all the dimensions, you'll get 95% accommodation. And we see that that's not the case here. Okay, so let's go ahead and see, do you have questions about this tool?
Tom,
Can
this is Dana. Oh, sorry.
I'm sorry, go ahead. Go ahead,
Go ahead,
take it.
Dana.
Of course, it's me and Kristen.
Okay.
For this tool, Tom, this is the one that's based on the Caesar data, which is based on North Americans. Is that correct?
It is, and it's also been reweighted so that it represents US civilians as of 2014.
Oh, okay, great.
Okay, so let's go back. I'll stop share for a minute and bring up the PowerPoint.
Tom, will it make sense as we move forward? I was confused about the percent male part at the top.
Oh, sure.
Yeah.
Go ahead.
I'm really just, if I were just thinking about the general population, I would just put that at 0.5, just to, if
Yeah.
I'm okay.
Yeah, and that when you do that, you're assuming that it's roughly a 50-50 mix between males and
Okay.
females.
Okay, that makes more sense. Yeah.
So an example of where we might want to change that is if we were looking at, National Football League football players, we'd want to, change that to 1. If we were looking at a typically female occupation like nursing or something like that, we might want to change it to, something small, 10% or something of that sort.
Or sure, or just find out about what if you were designing for a specific population that's doing a really, really specific thing, just generally finding out what that percentage looks like.
Yes.
And going from there. Okay,
Yeah,
that makes sense. Thank you.
Yeah. Okay. Good. So good question. So let's see. Now I've forgotten if I'm sharing. All right, let's take a quick look here. No. Okay. Okay. So you have the handout. In your handout, you have a copy of the virtual fit tool, but you can always download it for free from the HFES website. And this is the link. I think I sent that to you in a chat as well. So here's your task. Using the virtual fit tool in a 50-50 mix of males and female, you're going to do a chair design. So you're going to look at seat width, 95th percentile value of hip breadth seated. Seat depth is 5th percentile female buttock to popliteal length. The seat height range is 5th percentile female to 95th percentile male popliteal height. And the armrest for the chair height range is 5th percentile female to 95th percentile male elbow rest height sitting. So go into use the VFT and plug in the values for these, and then we'll come back in about 20 minutes and look at the percent accommodation. And I think what you'll see are some differences, even though each one of these will accommodate better than 90%. I think you'll be a little bit surprised at how much of the population, what percentage of the population is concurrently accommodated on all 4 dimensions. So we'll do that. We'll have one more exercise after that, and then that should give us some time. If you have examples, if there are things that you're working on that you'd like to talk about, what the accommodation would be, or questions about anthropometry in general, that should give us some time to cover that at the end of the session. So go ahead and put these data into the virtual fit tool. And then we'll come back in about 20 minutes or so and look at the results. And of course, if you have any questions or comments, either just ask through the microphone or send me a chat message. Okay, let's go ahead and reconvene here and talk about what you found. So in this exercise, you were asked to use the virtual fit tool, and you put in 4 different dimensions for a chair design. Each of those dimensions accommodated at least 90% of the population. But when all 4 were combined, what percent of the population was accommodated?
So for both, I got 81.7.
Yes, that's exactly. Well, that's what I got. We're going to declare that exactly right.
We're at least this.
Yes. So here's the slide, and let me go to full screen on that so it's easier to see. So even though when we look at each one of these 4, we've got better than 90% accommodation on all 4 of them, we only get a little less than 82% accommodation in total. So if you were designing to, or you were selecting a chair or designing a chair, and you wanted to specify that would accommodate 90% of the people, what you would end up doing is going in here and changing some of these values. Because it's almost always less than these, you'd want to go wider, or more range. So let me back out of this and actually pull up the virtual fit tool. So here's the one that I'd worked out. But for example, we might change hip breadth seated, because that's, again, as Kim reminded us earlier, we're really only looking at a minimally clothed individual. So light athletic shorts, t-shirt, barefoot kind of thing. So let's say, well, we need some allowance for movement or hip breadth. So let's change this to 550. So we're at 81.7% accommodation now. We change it, and we've got a little bit. So what else might we change? What would you all like to change of these 4 dimensions? Well, what if we change the height adjustment range? So we've got here 5th percentile female in that cell, 338 millimeters. So let's change that to, and I'm just making these numbers up, 320. Okay, so we're getting a little better. Well, let's change that to 500. Getting better. Let's see, what else can we change? Probably don't want to change that too much. Well, I guess we could. Let's change that to 400. Okay, now we're up to 87. And then let's change our elbow rest height sitting. Let's change that to 300. Okay, so that got us to our 91 or 90% accommodation. So I taught you this tool using the percentile values here, but you can realistically use anything you want in here. So if you had a chair come in that said, well, the seat depth is this much, the seat width is this much, the height range adjustment is this much, the elbow, the arm support height range adjustment is this much. You could plug those numbers in and it will tell you approximately what percent of the population is accommodated. Okay, does that make sense to everyone?
Yeah.
It's a lot easier than the other.
Yes, it is. And that was part of the point I wanted to make by having you go through all of those exercises before. This is a much simpler tool. The only problem with it is you're limited to these, whatever there are, I think about 20 different variables. Works pretty well for seated work, moderately well for standing work, but inevitably you'll find dimensions that aren't in here. So at least you've had some introduction to using spreadsheets to calculate what the accommodation would be with those. So our next exercise is to do a standing workstation evaluation. And I think what I'll do is I'll just walk through that with you rather than asking you to grind away on it. I'm just going to zero these all out. I run on an Apple computer, and usually it works okay, but sometimes if I don't zero all of these out, it doesn't work right. So that's why I'm zeroing these out. So let's take a look at the next problem set. Okay, so what I'm basically asking you to do in this set is to look at the accommodation for somebody, a 95th percentile male who's standing, and we want to put the bench that they're working on at roughly elbow height. And then the second thing that we want to look at is what is the reach distance or the depth of that workstation. So the two variables that I've used are standing elbow height and elbow to fingertip reach. So this is the way to do it with the answer data, but let's do it first with the virtual fit tool, and then we'll come back and do it with the answer data. Okay. Okay, so down here we do have some standing measures. So I said a 95th percentile male, elbow rest height, 95th percentile, 1,177 millimeters, and elbow fingertip length, 512 millimeters for 95th percentile male. Okay, so that tells us that we're doing pretty well for men. It tells us that we've accommodated 99% of females and 95% of the joint population. I think you might want to take this with a grain of salt, because now if we put this in for 5th percentile female, 386, and 914. We're only getting about 90% accommodation, which isn't too bad. We could certainly live with that. So that was pretty simple and straightforward to do with the virtual fit tool. Now let's look at doing it the brute force way. We'll do that. I'll walk through it with you, and then we'll have some time at the end for questions. Any problems that you are dealing with that you'd like to talk about, or just questions about anthropometry in general. So let's pull up, this is female data, so I need the male data. Bear with me here. Okay, so on the problem sheet, you'll see that this is another instance where standing elbow height isn't given. So we're going to need to estimate what that is. Let me clear all of this out. Okay, so the way that the answer folks said that we need to do this is we need to combine 3 variables to get standing elbow height. So we start off with elbow rest height, which is AH2 plus stature, I think. Yes, which is BX2 plus, and then minus the sitting height, which is BT2. Okay, so that's combined each of those 3 measurements for this one individual. Now we need to do that for everybody in the sample. So this is how we'll do that. Okay, so that's given us our values for that. That tells us what elbow rest height standing is. So now we're asked to determine the 95th percentile value. Okay, so this is the percentile function that you worked with before. DF2, DF4803, comma 0.95. And it tells us that that's 1,163 millimeters. So the next thing we need to do then, we can let the standing elbow height rest for a minute. And we want to look at the forearm hand length. And that is variable AO. So we need the, okay, 95th percentile variable of that. I can't spell. And okay, now it should work. Okay, so now we have the 95th percentile value for elbow rest height standing, and for forearm hand length, we need to look at how many people are concurrently accommodated by both of those dimensions. So we're going to back to our count if statement. DF2, DF4803. AO2. Okay, equals. Okay, I think I got the statement right. Nope, not yet, apparently. Okay. keep doing that. Comma, quote. No. All right, let me start over. DF2, DF4803. All kinds of typing errors in here. All right.
Your quotation mark for 519.95 shouldn't it be on the other side of the arrow?
Oh, yes, you're right. Thank you, Keith.
Hey, no worries.
All right. Thank you for your help. You can see that even when you work with this stuff all the time, you still end up making mistakes. So what's our percentage of people that are accommodated? About 78%, according to this. So again, this is just an illustration of why you want to be careful when you use percentile values to define something. So how many would say that it was easier to do this using the virtual fit tool? I would. I don't know about all of you, but I think it's a much simpler tool. I have some more material in the handout, and I'm happy to talk about that because it's stuff that I do all the time. But I want to ask first if there are any problems that you're working on that you'd like to talk about how we might work on estimating the accommodation. Or any questions about anthropometry in general.
So comparatively speaking, in looking at answer versus, oh gosh, the second one, VFT, I think, wouldn't we find that the VFT would be a more representative of the population just because it isn't based on the military data?
Yes, absolutely. I would use the VFT anytime you could because it's weighted for a North American civilian population.
Okay.
The only time, and I guess I should have made this clear in the presentation, the only time I'd recommend using the answer data is if you're working with a military population, or the second is you can't find the variables that you want to look at in the VFT tool. And then you have to go through this whole process that we just looked at of doing it by the brute force method.
Do you possibly have maybe a guideline that's pretty straightforward on how to navigate in the ways that you just showed us? Because I feel like I wrote notes kind of all over the place, but I'd love to have it in one place.
I don't, unfortunately, other than these slides. I'm always happy to answer questions. I'll put my email up and my phone number as well. So if you're trying to work through some of these problems, I'm happy to talk to you because I actually like doing anthropometry, and I think it's fun. So I'd be happy to help you if you have questions.
And then one other question is the PDF that is associated with the answer.
Yes.
How would you recommend utilizing that as a resource?
So that's a summary report. Let me find that and share that with you.
I started to print it and then.
Oh yeah, that's, there's a huge amount of data there, isn't there? Okay. One of the main reasons that I put that in there, when I first started working with anthropometry, 30 years ago plus, I used an earlier version of the answer data. And one of the first things that I used was the visual index. So it's, and I think that's what you're seeing now on your screen is the visual
Yeah.
index. Okay.
Yeah.
So
So
you
the-
can look through this and you may not know what to call something, but in this case, if you were looking for, let's say, a glove length, you could look at this photo and say, okay, that's probably going to be related to dimension 44. And then you can go back and find out that that's, hand length. Let's just try to find that here quickly. Which dimension? Okay, 14. So the numbers on those should correspond to these data points. And these are all percentile data, but they also give you the mean and standard deviation. Foot length. $41, $42. Okay, so this one is hand breadth. Was it 42 or 44? It was in the index. Let's see here.
44.
Yeah, okay. Yeah. So here's the data. It again shows you this picture of how it was measured. Gives you the percentile data. Then there should be, it's going to tell you what the average or the mean is in both centimeters and inches. Tell you what the standard deviation is. All of those kinds of things that you were calculating by hand before. So this has, starting on page 389, this is the PDF, has the visual index. Somewhere around here. The PDF numbers, I don't think correspond exactly to the, yeah, here we go. Don't correspond exactly to the page numbers in the original document. So this is the visual index, and you can just scan through and see what dimension you think you might be interested in. Okay. The only thing I would caution you about with this, again, is that if you use this, just remember that these are percentile values. And when you combine percentile values, if you're using a multi-dimensional design, if you have more than one dimensions that you're looking at, like the chair that we just looked at, where we had 4 dimensions, you will almost always get a smaller percentage than the percentile values that you've used. Okay. All right, I think that's probably enough of confusing you about the PDF, the technical report. Other questions? Okay. All right, so in summary, let me pull my PowerPoint back up here. And okay, so there are some different methods. If you work with military, for example, they have used something called principal component analysis to calculate what the combined measurements are, but I think we won't go into that today. So we looked at different data sets. We looked at the answer to, which is the 2012 Army data. That's available for males and females. We looked at the Human Factors and Ergonomics Society virtual fit tool. Excuse me. We looked at the ISO 7250-2 document. While both of these are, let me put that up in full screen, sorry. So these two are pretty much dedicated to North American data. This one is sort of global data. It has North America, Europe, and Asia. I don't think there's any South American data in it. Caesar is certainly available. You can purchase it from the Society of Automotive Engineers. As I mentioned earlier, the last time I checked, the price for that runs about $3,500. It's not the most user-friendly software in the world, but it is there if you want to take the time to learn it. NHANES is done every year or so, and that's published. But again, it's a very limited amount of anthropometric data and typically reported as percentiles only. If you're interested in going back in history, you can look at the answer 1 data. This was the 1988 survey of the Army at that time. And it's interesting to see the bony dimensions that we talked about at the beginning of the session haven't changed that much, but the flesh dimensions, the circumferences and such have changed fairly markedly. So,
Tom,
yes.
that Size North America study, the
Yes.
Size North America study that they were doing in Canada, is that, you have any comments on that one?
I don't know it very well, so I guess I can't really say what it has. I think that's also, you have to purchase that as well, don't you? To have access to it.
They kind of bought, you could, if you bought in early and you needed specific to make requests, I think, about certain things that you wanted them to collect data on. But I wondered what your thoughts were, I think, about what they were collecting versus what existed already.
Well, if they're collecting data now, they're going to be roughly 10 years newer than the Caesar data. And I would expect to see pretty stable length and height type measurements, but I would expect to see some increases in the circumferences, especially if it's civilian data. Because
Yeah, I believe it was.
Okay, because as we know, our body mass index seems to keep going up. I did a study 3 or 4 years ago. We looked at data from 1968 up until 2000, did we do the 2017, I think, looking at some data from the Netherlands and Europe. And we found the same kind of thing, roughly 2.5–3% increase in those fleshy dimensions per decade. So if this group that you're talking about is collecting data now, I would expect that trend will continue, and that you would see things like greater seated hip breadth, greater waist circumferences, and those kinds of things. But as far as our methodology and that sort of thing, I don't know it, so I can't really comment on it. There are some other data sets. I'm sorry, didn't mean to cut you off. There are some other data sets.
Oh, that was it. I was just saying, okay, I don't.
There are some other data sets that will use something called proportional scaling. And I would suggest that you avoid those because they may be better than nothing, but I don't think a whole lot better. That's my personal opinion. Okay, so these are some of the things that we talked about, and I hope that I didn't confuse you too much. You've had an introduction of how to use anthropometric data and use Excel to calculate accommodation fractions, or the percentage of people accommodated. We talked about univariate and multivariate accommodation models. Univariate single dimension percentiles are perfect for that. They'll be spot on as far as telling you what the accommodation is. But unfortunately, most designs are multivariate, multiple dimensions, and combining percentiles, using percentile values to do that can often be misleading. We talked very briefly in the cart example about estimating biomechanical loads imposed by designs. So using the anthropometric data that we had and some of the common assumptions about cart designs, for example, we were able to get a ballpark estimate of what the moment applied at the shoulder would be for someone pushing a cart. And then that in turn could be used to evaluate the potential for risk. We used Excel to look at accommodation when we combined two variables. The example that I used for that was seated eye height above the floor. Because Excel didn't have that as a direct measurement, we had to combine two different measurements and then calculate things like percentiles to get the accommodation. Then the part that I didn't talk about is sometimes you face a situation where you only have percentile data available. And there are methods to estimate accommodation when all you have is percentile data. And I'd be happy to talk with you about those if you want to email me or call me. But I don't think we'll talk about those today. Let's see, there are some other multivariate techniques used. Two that you'll hear very commonly are principal component analysis. That you really need, that's a pretty specific skill set. So you really need people that are experienced in doing that. Claire Gordon, for example, developed the Army's principal component analysis models for seated workstations and standing workstations. I didn't go through those today because of the point that was made earlier about would it be better to use civilian-based data for civilian workforces. But it is out there if for whatever reason you wanted to look at that. Okay, so we've got about 20 minutes left here. Let me put up my contact information, and let's just do that quickly here. So that's my email and my cell phone. Is here. So I'll leave those up. Okay, so questions in general, anything we talked about today or other anthropometry questions? Okay. If not, thank you. Hopefully you weren't more confused than I was about using Excel. I think the VFT is a really useful tool. I hope that you're able to use it. And I hope that we can talk the human factors and ergonomic society into expanding the number of variables. All right. Thank you for your time. And I guess we'll stop here.